everyone, my name is Dalit Soni and I welcome you all in this new series by Drishti IAS, that is Target UPSC Prelims 2024. In this series, we will be discussing important current affairs, or you can say that it is important current affairs revision for you, that will be subject wise or you can say section wise. Okay, in this particular episode, we will be talking about science and technology section. So we will be discussing few important topics which has been in news and that can be important for your prelims examination. So let's start without any delay. In this series, we will be talking about certain topics and that will be a very crisp series and we will not go into much details of it. We will go cut to cut, point to point. Okay. So let's start. First topic is related to your Aditya-L1 mission. Why it is in news? Because recently it was launched from India and it is India's inaugural solar mission. Okay. So you know that inaugural solar mission here means that it is the first mission to, you can say, sun. Now here you can see there are certain important aspects of Aditya-L1 which has been given in this infographics. We have added these infographics so that you can take a screenshot and directly revise from that. Okay. So it was launched on 2nd of September. And the distance at which this particular satellite will be placed, that is nearly 1.5 million kilometers. Obviously, the temperature of sun is too high. We cannot go too close. That is why we will be observing it from a particular distance. Okay. Afterward, when we are talking about the cost of this particular mission, that is nearly 378 crore. So we don't have to remember all these things. But the thing is, there are certain points here. You can see it is first Indian space-based observatory class mission, that is a solar mission. When we are talking about the first Indian space-based observatory, that is ASTROSAT. Okay, you must have heard about it. ASTROSAT. Okay, but when we are talking about the first solar observatory, that would be your Aditya-L1. Okay, so I guess this is clear. Now second point is to be launched by ISRO's PSLV XL rocket from Satish Dhawan Space Center, that is in Sriharikota. So this particular space center is quite important. Location of this space center would be important for you. Second thing is where we will place this particular satellite. So basically we are going to place it on the Lagrange's point number 1. Okay, so what is Lagrange's point we will be talking about in the further slide, but right now just remember this much. Okay, major objective is to understand corona, solar wind, solar atmosphere, sun flares and near earth space weather. So we will be talking about that in detail. Here you can see Aditya-L1 is the first space based observatory class Indian solar mission to study the sun from a substantial distance of 1.5 million kilometers. Obviously, as I told you, we cannot go very close to the sun. The spacecraft is planned to be placed in a halo orbit around a point that is Lagrangian point number 1. So here you can see this is L1, that is Lagrangian point number 1. And when we are talking about the orbit around it, this orbit around it, this is basically your halo orbit. Okay. So we will see what L1 is, but for that you have to wait a little bit. It will take approximately 125 days to reach at the L1 point. Okay, here you can see certain this is the your Aditya-L1 and this is the distance from this L1 point to earth, that is 1.5 million kilometers. Okay, now coming forward, here you can see the objective of the mission is to provide valuable insight into the solar corona, photosphere, chromosphere and solar winds. Okay, so basically here you can see this is the internal structure of the sun, wherein you can see this part is the core, then we have radiative layer, then we have photosphere, this sphere outside, this is photosphere. Okay, and we will be actually learning about or studying photosphere, then outside another layer is that is chromosphere, and then outside the outermost layer, or you can say the impact of these chromosphere, that is corona. So these three layers will be important from this particular satellite's point of view or this mission's point of view. And then we will also be studying these solar winds. Solar winds are nothing but you can say there are various mass ejaculations from sun, and because of which the wind around that, or you can say these emissions from the sun are basically comes in the form of solar winds. Okay, so we'll be talking about that as well. Now the primary objective of Aditya-L1 is to gain deeper understanding of the sun's behavior, including its radiation, heat, particle flow and magnetic fields, and how they will impact the sun. So basically, because of the solar winds, you must have seen that the communication satellites stop working, or there is some kind of distraction or obstruction in their working. So that is why studying these solar flares, solar winds are important, so that we can go for a corrective actions. Okay, so we will be studying about the all these masses which are getting emitted from the sun. Other than that, the radiations, heat, particles, and the magnetic field around the sun. Okay, now coming to the next point, that is related to your Lagrange's point. As I told you, we will be placing this satellite in the Lagrangian point. Okay, so in the Earth and Sun system, actually these points can be in any two body system, but when we are talking about the Sun and Earth, here you can see this is your Sun, this is your Earth. Here there are certain points. Okay, so there is this point between Earth and Sun, that is L1 point. Then we have this L2 point. Okay, L3 point, L4 and L5 point. Now when we are talking about these points, what is happening here is that any body will have a centripetal or centrifugal force. Okay, then any body will have a rotational force as well, and any body will also have the gravity between these two bodies. Okay, so these are certain point where this gravitational pull or other forces are basically, you can say, resultant in such a way that this body can be stable in that particular point. Okay, so this orbit, or you can say this point here, this body will be stable. Okay, so these points can be considered as parking spots. These are parking spots for the satellites. Now you know that satellite has this tendency to, you can say, observe the sun, etc. So that is why what we are doing here is that in around this L1 point, we are having this halo orbit. On this orbit, we are placing this satellite so that it can have a clear picture. From this, it will cover this area, and from this side, it will cover this area. So basically, we will have a clear picture of the sun. Okay, from this particular halo orbit. Okay, I guess this is clear, and this is enough for Aditya-L1. Another thing here, you can see Aditya-L1 is also ISRO's second astronomy observatory class mission after AstroSat. Okay, as I told you, when we are talking about the solar observatory, this is the first one. When we are talking about the observatory as an overall feature in the space, AstroSat was launched in 2015. Okay, now the next is the mission's journey is notably shorter than the Mangalyaan. When we sent Mangalyaan, this journey of this Lagrangian point to reach satellite to this particular point will be shorter than the Mangalyaan. Okay, now we can move to the another article that is related to your Chandrayan. So these Aditya-L1, Chandrayan, NISAR, all these things are basically, you can say, successful achievements of ISRO. Okay, so in the space section of your science and tech, these satellites becomes important. Okay, now Chandrayan, why it is in news? Chandrayan has been made, Chandrayan 3 has made history by becoming the first mission to soft land on the lunar south pole, a region that has been never explored before. Okay, earlier also when we are talking about the moon, there are various countries, or you can say 3 countries. One is USA, second is Russia, third is China. These countries has gone for landing on the moon, but they have gone on the north pole, okay, and not on the south pole. So when we are talking about the north pole or overall landing on the moon, India has become the 4th nation to land on moon, and we can say India has become the first nation to land on the south pole of the moon. Okay, now landing on south pole is quite difficult because of the topography of that particular area, which we will be discussing. But right now, just remember that this has landed on the south pole of the moon. Second thing is, here we are talking about the soft landing. Soft landing means that there is no impact. Okay, the satellite went, and then after full control, it has landed on the surface without any kind of huge impact. Okay, so that is what soft landing is. Okay, now when we are talking about other missions, we also have Chandrayan 1, then we had Chandrayan 2. Okay, so Chandrayan mission as a trilogy, or you can say Chandrayan mission as a whole, or you can say moon mission, has given a significant amount of exploration, significant amount of insight from the moon. And we have also said that there is water on the moon surface, and that has been discovered by this Chandrayan mission itself. Okay, now coming to the Chandrayan 3, we have sent this as a succession to Chandrayan 2, because at the time of Chandrayan 2's landing, the Vikram lander could not land in a particular way, or you can say could not soft land on the surface. Okay, so because we could not establish the communication with that, that is why we can say that the Chandrayaan 2 was a partial success, okay, but the orbiter which was sent in the Chandrayaan 2 was there, and that was working fine. So that is why in this particular mission we have sent only the lander and the rover, and orbiter will be used of Chandrayaan 2, okay. Now the mission aims to demonstrate safe and soft lunar landing, rover mobility, and in situ scientific experiments, okay. India now joins the United States, Russia, China as one of the few countries which has successfully landed on the moon, which we have already discussed. Now moving further, here you can see this particular mission has this satellite launch vehicle. That satellite launch vehicle was GSLV Mach 3. This is the advanced version of GSLV as of now, okay. This is the you can say most advanced satellite vehicle we have as of now, okay. It has been launched from the Satish Dhawan Space Center, Sriharikota, which we have talked in the Aditya-L1 as well. Now destination was Moon South Pole region, we have discussed that. Other than that, the cost was 615 crore. This is not much important. The thing which is important is this launch vehicle, that is GSLV Mach 3, okay. Now there were propulsion module, then Vikram lander and the Pragyan rover, okay. Pragyan rover and Vikram lander, they were sent in the Chandrayaan 2 as well, but they could not soft land, and because of which we sent them again. The orbiter which was sent in the Chandrayaan 2 is still there, and it is working fine, so we will be using that orbiter. So what will be the job of this particular experiment, wherein Vikram lander will land there, and then this Pragyan rover will come outside of the lander, then perform certain activities. It will send the data to the lander, and lander will send the data to the orbiter. So that is the whole process of Chandrayaan 3, okay. So let's move further. Chandrayaan 3 aimed to investigate permanently shadowed region near the South Pole for potential water, ice and resources, okay. So basically we are going for the Chandrayaan 3 which is landing on the moon's near side, okay. So there are two sides, that is near side and far side. We are going for the near side. Near side means that particular area, or you can say that particular face is close to the earth, okay. So Chandrayaan 3 aimed to investigate the permanently shadowed region near the South Pole for the potential water, ice and resources. While a notable achievement, Vikram's lander occurred on the moon's near side, unlike China's Chang'e-4 that is on the far side, okay. So I would like you to remember this particular satellite's name, that is Chang'e-4, that belongs to China. UPSC has asked about this particular mission once, so I would like you to remember the name. So now we can move further. So why on the South Pole, okay. So rocks and the soil composition of the South Pole can give idea about the origin of the solar system. When we are going for any kind of exploration or any kind of satellite based studies in the space, the ultimate aim is to know what is the origin of the universe, what is the origin of the solar system, what is the origin of the earth. All these questions are there, okay. So now when we are talking about this South Pole, so why this is important? Because the South Pole is an area wherein there are various deep craters, okay. Craters you can understand as a deep holes, etc. So there are various craters, and because these are so deep that there are places where sunlight has not reached for like thousands of years, and that is why the you can say origin or the growth of that particular area is slow. So we can study that particular area, okay. So here you can see this is moon South Pole, and this particular area here, which is in this area, is basically a crater, okay. So temperature in this crater is nearly minus 267 degree Fahrenheit. So you can say that since sunlight has not reached that particular area, so that areas are undisturbed areas, okay, and because of which we can go and study those areas, and because on the basis of which we can come up with a theory for the origin of the solar system or earth as a whole, you can say. Now on the South Pole we have difficult terrain, less sunlight, lower temperature, more unknowns are there, and it is undisturbed. And since it is undisturbed, we can explore and get few answers, okay. That is why we have gone for the South Pole of the moon. Now what are the intended actions for the Chandrayaan 3's landing? As I told you earlier also, it will go for some in situ experiments, and from where it will take data, images, and it will send it to the lander, and lander will in turn send it to the orbiter, okay, and this orbiter will transmit them to the station which are in the set up on the earth, okay. So this way this particular functioning will work. Now Chandrayaan 3 is expected to operate for at least one lunar day, that is 14 earth days, okay. on the lunar surface. So when we are talking about this particular lander, we are saying that it will be there for at least 14 days of your Earth cycle, and when we are talking about lunar cycle, that will be 1 lunar day. Okay, so that is about your Chandrayan. I hope this is clear. Other than that, there was this particular payload, that is spectropolymmetry of habitable planet Earth, that is SHAPE. Okay, this is also there with the Chandrayan. The propulsion module that carried the lander and rover configuration until 100 km lunar orbit also has a SHAPE payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. Okay, so there was another payload which is on the Chandrayan, a propulsion module, that is SHAPE. So you can remember the name or this particular full form of this particular name. Okay, they might ask you, but there are very less chance of this. Okay, one more thing here is that they are talking about this 100 km lunar orbit. So why is that important? Because when we are talking about the method through which they have sent it, so let's say this is your Earth, okay, this is Moon. So what we have done is that we have launched the rocket. It will start orbiting this Earth, and then slowly it will move in this particular direction, and it will exit the Earth's orbit. Okay, once it exits the Earth's orbit, and it will enter the Moon's orbit, and it will move around it, and slowly it will go close to the Moon, and at a particular altitude of 100 km, it will be propulsion module will be there, and from that 100 km, lander will be going towards the Moon's surface, and lander will go in such a manner that we can control the direction as well as the velocity of the lander, and so that we can easily go for the soft landing. Okay, now moving further, third is your NISAR, NASA ISRO synthetic aperture radar. You must have heard about it. It has been in news for a while now. Okay, this particular agreement related to this we can say NISAR module was signed in 2014, and it was expected that we will launch it in January 2024, but we are expecting it in 2024 itself. Okay, now recently NISAR has received a send-off ceremony at the NASA's Jet Propulsion Laboratory, JPL, in California. Okay, so this news is not important, but just the reference we have given that it was in news. Now NISAR will be the first radar of its kind in space, systematically mapping the Earth using two different radars. This is first of its kind because they are using two different radars, that is, one is L-band and second is S-band synthetic aperture radars, which we are using in NISAR instrument to measure changes in our planet's surface less than a centimeter across. So basically the precision will be like that. If there is a movement in a less than a centimeter area, this particular you can say instrument or this particular mission can actually get to know about that. Okay, so precision is very high. Okay, and when we are talking about this mission, this is a mission which is done by a joint partnership of NASA as well as ISRO. Okay, so that is why it becomes even more important. Here NISAR has been built by the space agencies of USA and that India under a partnership agreement signed in 2014. It is expected to be launched in 2024 from the Satish Dhawan Space Center. So that is why I was telling you, please remember this name because it has been launching various satellites this year. Okay, now the satellite will operate in a minimum of 3 years. Operate for minimum of 3 years. Okay, so lifespan of this satellite will be 3 years, and it is a low Earth orbit observatory because the job of this satellite is to observe the Earth's surface and the activities on the Earth's surface. So that is why it will be a low Earth observatory. Okay, now NISAR will map the entire globe in 12 days. Okay, so the system or the satellite has been designed in such way that it will actually map the entire Earth in 12 days. Okay, now moving further, there are certain benefits which are expected out of NISAR, that is related to information about the Earth's surface changes, natural hazards and the ecosystem disturbances will be collected by NISAR and sent to us so that we can take the corrective measures. Then information to help manage disaster management, or you can say natural disasters. Then to improve agriculture management and food security by providing information about the crop growth, soil moisture and the land use changes, because this you can say satellite has this particular precision nearly a centimeter, so they can also go for the crop growth, looking for the information related to crop growth, soil moisture, etc. to monitor and understand the impact of climate change on our planet. So this is very important because right now this is climate change has been the hot topic. So that will be very important for this satellite to monitor and understand the impact of climate change on the planet, including melting glaciers, sea level rise, and changes in the carbon storage. Okay, so that is about NISAR. Here you can see a picture of NISAR. So there are two components here. You can see this is this colorful component here. It has been designed by NASA. Okay, and the component here, this solar panel and the propulsion module, this here. Okay, this has been designed by ISRO. Okay, so we can say that the antenna and this particular aperture radar, this was basically designed by USA, and this panel has been designed by India's ISRO. Okay, now moving further, next article is related to your Artemis Accord. So Artemis Accord has been in news from 2020. So there are chances they might even ask you about this accord, what is it about, etc. Why it is in news? Recently, India's Prime Minister announced India's decision to join Artemis Accord during its visit to United States. Okay, India became 27th country to sign the non-binding Artemis Accord. So basically, it is non-binding. Okay, so it will not have any kind of legal sanctions. It will have a moral sanctions. Okay, now moving further, what is it about? Here you can see Artemis Accords are established by the USA, okay, with 7 other founding members. This I would want you to remember the name of these founding members. One is USA, second is Australia, third is Canada, Italy, Japan, Luxembourg, and the United Arab Emirates and United Kingdom. Okay, so it was started in 2020. So this year of origin is important. The aim was to set common principles to govern the civil exploration and use of outer space for the peaceful purpose. So basically, these are governing some set of laws, or this is going to set up some laws or rules which are to make sure that the use of space is done for the peaceful purpose. Okay, it builds upon the foundation of the Outer Space Treaty 1967. So this Outer Space Treaty also talks about the rules and regulations which is for the peaceful use of the space. Okay, so we'll be talking about this particular treaty. Before that, you can see these commitments under the Artemis Accord. So use of space for the peaceful purpose, then common infrastructure you can build, and that can be used by these member countries. Then we have registration and data sharing. Data sharing will be done from time to time, so that is another advantage of it. And then preservation of the heritage. There are certain sites, let's say when Chandrayan has gone there and they have landed that particular point, that point was named something, that point was named Shakti. So such points are basically your heritage. Okay, so such heritage should be preserved. It should not be the case that once India has went there and they have put some, you can say, their flag over there, and then another country goes and they will take it off. Okay, so this is not the case. You have to preserve these heritage sites. Okay, so this is for the peaceful use of the space, and exploration there should be for the peaceful purpose. Okay, it is to recognize that space is a, you can say, shared resource and not ownership of one country or another. Okay, now coming to the Outer Space Treaty of 1967, this is quite important for you. It is a multilateral pact under the United Nations. So obviously it is under United Nations, so that becomes important. Serves as the foundation for international space laws. Okay, so this is the foundation which has been set up in 1967, and on this particular model we have come up with the Artemis Accord, which are basically you can say grouping of Western countries, and certain countries like UAE and India are also part of it. Now the treaty emphasizes space as a shared resource for humanity, prohibits national appropriation, and encourages peaceful use of the space. The objectives are same, I guess. Okay, now moving further, next article is related to your Nipah virus. Nipah virus has been in news because recently it was resurgence was seen in the Kerala. Okay, there were 2 fatalities in Kerala, and that is why Nipah virus was in news. So there is some specifics about Nipah virus here. It is a zoonotic virus. Okay, it is transmitted from animals to humans. When we are talking about the zoonotic viruses or bacteria or any body which is zoonotic, here we means is that it can be transmitted from animals to humans. Okay, so when we are talking about corona, so corona was also a zoonotic virus. Okay, the organism that caused Nipah virus encephalitis is RNA virus, or you can say ribonucleic acid virus, and is closely related to the Hendra virus. Okay, So this is about the Nipah virus. It is a small introduction here given. Now when we are talking about another article that is related to your SIPRI report, okay, India remains the world's largest arm importer from 2018 to 2022. When we are talking about this SIPRI reports, this basically gives you an idea about the arms and arsenals, or you can say weaponry, which countries has, who is the largest importer, who is largest exporter, which country has seen an increase. All these activities related to weapons and defense systems are basically comes under this particular SIPRI report. It is published by Stockholm International Peace Research Institution. Okay. So that particular institution becomes important for you. Okay. So in 2018 to 22, it was seen that India remains the world's largest arms importer from this particular time. Russia was India's largest arms supplier in this period from like 2013 to 17 and 2018 to 22. So we can say that Russia is the largest you can say arms supplier to India. Now there are certain data which you can remember here. You can see there are top 5 importers, and in that list India is first, then Saudi Arabia, Qatar, Australia and China. When we are talking about the suppliers to India, so Russia is the largest supplier, and then we have France, and then we have USA. When we are talking about the India's procurement or defense procurement, there are nearly 45% procurements are done by Russia. That is why Russia is an all-weather friend. Russia is a reliable partner. Okay. Other than that, when we are talking about the France, it is nearly 30%, or you can say 29%, and USA is 11%. Okay. India also imports from the Israel, South Korea and South Africa. Okay. So these are certain things you can remember. When we are talking about the nuclear warheads, okay, so number of nuclear warheads, maximum is with Russia, then USA, then China, France, UK, Pakistan and India. So Pakistan has 5 more nuclear warheads than India. So that is why we can say that India is at 7th number when we are talking about the nuclear warheads. Okay. So first know that Russia is the largest one and not USA. Russia has the largest number of nuclear warheads, and then USA, and then we have China, and India is 7th. Okay. Now moving further, here are certain there is this drone that is �MQ-9B. Okay. There is this company that is General Atomics. They have come up with this drone that is �MQ-9B high altitude long endure HALE unmanned aerial vehicles. So basically the drones are called unmanned aerial vehicles. So it is a high altitude drone. They will be assembled in India. Now the agreement says that they will be assembled in India. So that would be a good thing, because when there is assemblies, there are high chances that we will go for the manufacturing in the further phases as well. Okay. So will enhance the intelligence, surveillance and the reconnaissance ISR capabilities of India's armed forces across the domain. Okay. So that is why it becomes important. Here are certain things about this drone which you can go and read at your own, because there is nothing much. You don't have to remember all this data related to weight and what is the fuel capacity, etc. Only thing you can remember is it's a drone which can be controlled by 2 pilots at the station on the earth. Okay. So that is one thing. Second thing, it can go for the laser guided missile, anti-tank missile, anti-ship missiles. Other than that, there are various missions for which these drones can be used, that is humanitarian assistance, search and rescue operations, law enforcement, border enforcement, defensive counter-air, airborne early warnings, electronic warfare, anti-surface warfare, anti-submarine warfare, airborne mine countermeasures, long-range strategic ISR and over-the-horizon targeting. Okay, so these are certain things for this particular drone can be used. Okay, here as a part of this plan, General Atomic will also establish the comprehensive global maintenance, repair and overhaul MRO facility in India in support of India's long-term goal to boost indigenous defense capabilities. Okay, so these are the certain things which we have discussed in this particular episode. We will come up with another episode in a few time, so keep a tap on that. I'll see you in next episode. Till then, have a good day. Thank you.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.